Imagine you had a cosmic shrink ray, not your average sci-fi toy, but the kind that would make mad scientists drool, and you aimed it straight at the sun. Zap! Suddenly, that massive, flaming powerhouse shrinks down to the size of a basketball, while Earth, poor thing, now looks like a lonely sesame seed rolling around in the cosmic void, probably questioning all its life choices. Sounds crazy, right? Well, buckle up, because we're about to take this absurd scenario one step further. What if the sun actually became smaller than Earth itself? Things get very weird, very fast. The sun, the big boss of our solar system. The sun isn't just some ordinary celestial object. It's the heavyweight champion of our solar system. To put its size into perspective, you could fit about 1.3 million Earths inside the sun's volume. That's not a typo. If you could somehow stack up that many Earth-sized balls into a gigantic sphere, you'd finally have something that could rival the sun's bulk. And when it comes to mass, the sun takes up 99.86% of the entire mass of our solar system. That means everything else, planets, moons, asteroids, your lost car keys floating in space, is just fighting for the scraps of that remaining 0.14%. From Earth, the sun might not seem so enormous. After all, it fits neatly into the sky, right? But that's just because it sits a comfy 150 million kilometers, 93 million miles, away from us. Trust me, if the sun was sitting next door, you'd notice. Why size and distance matter. The sun's size and our distance from it are a cosmic Goldilocks story. We're not too close to get fried like Venus, nor too far to freeze like poor old Mars. Instead, we're sitting comfortably in what astronomers call the habitable zone, the sweet spot where liquid water can exist and life can flourish. Our happy little spot in the cosmos has been made possible by a delicate balance. The size of Earth, the size of the sun, and the distance between them. Tinker with any of these variables, and you've got a recipe for disaster, or at least a very different planet. What if the sun was smaller than Earth? Okay, now let's fire up the cosmic shrink ray again, and get to the juicy part of our experiment, making the sun smaller than the Earth. At first glance, you might think this wouldn't be such a big deal. After all, stars come in different sizes, right? The sun is not even the biggest star out there. It's not a supergiant like Betelgeuse or Rigel, nor is it the tiniest star we have found. But here's where things get a little tricky. The science of star sizes. A star's size plays a massive role in its characteristics, its color, temperature, and even its lifespan. Larger stars tend to be hotter, bluer, and live fast, dying young in spectacular supernovas. Smaller stars, like red dwarfs, are cooler, redder, and live for billions, even trillions of years. Our sun sits comfortably in the middle as a G-type main sequence star, or simply a yellow-white star. But for a celestial body to actually qualify as a star, it has to meet one crucial requirement. It must sustain thermonuclear fusion in its core. This process fuses hydrogen atoms into helium, releasing enormous amounts of energy, which in turn produces the light and heat we bask in every day. The fusion threshold. So how small can a star get before it's no longer a star? The smallest stars we discovered are red dwarfs with masses roughly 10 times that of Earth. That's about the bare minimum needed to sustain fusion. Any smaller, and fusion can't happen. Instead of a star, you're left with a brown dwarf, basically a failed star, or a stellar remnant like a white dwarf, neutron star, or black hole. So if our sun was somehow reduced to being smaller than Earth, say, 1 Earth mass, or even less, it would lose its star status completely. No fusion, no heat, no light. Just a cold, dark object floating in space like some kind of cosmic snowball. The gravitational domino effect. Now here's where things really start to spiral out of control. The sun isn't just a giant space heater, it's also the gravitational anchor of the entire solar system. The sun's massive gravity keeps all the planets, moons, asteroids, and comets locked into their orderly orbits. Without that gravitational pull, Earth and its planetary siblings would drift off into the void of space like kids losing their parent in a shopping mall, except far more terrifying. With the sun reduced to a puny, cold object, the gravitational structure of our solar system would collapse. Earth would become a rogue planet, wandering aimlessly through interstellar space. And without the sun's warmth, temperatures would plummet. We are talking about instant, planet-wide deep freeze levels of cold. Could life survive this cosmic horror? Not really. Without the sun's light and warmth, photosynthesis would stop, plants would die, and the food chain would unravel within weeks. The oceans would eventually freeze over, leaving only a small, thin layer of liquid water beneath the ice maybe. Any surviving life would be relegated to deep-sea hydrothermal vents or subterranean geothermal pockets, surviving off chemical energy rather than sunlight. And even those hardy extremophiles wouldn't last forever. As the planet continued to cool, even geothermal energy sources would dwindle, leading to the eventual extinction of virtually all life. Basically, Earth would become Hoth from Star Wars minus the rebel base and snow monsters. Let's flip the scenario. But what if, instead of shrinking the sun, we went full-on cosmic ego trip and made Earth bigger than the sun? To outmass the sun, Earth would need to bulk up by a factor of at least 333,000 times. That's a lot of protein shakes. At that size, Earth's gravity would be so immense that it would start to collapse under its own weight, compressing its core to the point where nuclear fusion would ignite. Congratulations, Earth, you are now a star. Of course, this new star Earth wouldn't exactly be hospitable for human life. Because it would be, well, on fire. The atmosphere would be incinerated. Oceans would vaporize. Every surviving houseplant would spontaneously combust. In short, not ideal for a Sunday picnic. A binary star system. If Earth transformed into a star, we'd effectively create a binary star system, two stars orbiting around a shared center of mass. This isn't just science fiction, by the way. About 1/3 of all star systems in the universe are actually binary or even multiple star systems. Some of these systems even have stable habitable zones where life could theoretically exist. Picture a world like Tatooine from Star Wars, with two suns shining in the sky. Pretty epic, right? Well, not if you are standing on what used to be Earth. In this binary setup, life as we know it on our original planet would be completely vaporized. However, there's a slim chance that life could develop on other planets or moons within the system, assuming the gravitational ballot of two stars doesn't fling them out into deep space. Lessons from the stars. So, what's the moral of this mind-bending tale? In the universe, size absolutely matters. So does mass, distance, and gravity. Our sun is not too big, nor too small. It's not too close, nor too far. It's just right. We exist in a razor-thin window of perfect cosmic conditions that allow life to thrive. The more we understand how easily this balance could be upset, the more we should appreciate the precarious miracle of our existence. And hey, the next time you complain about a hot summer day, just remember, you could be living on a frozen rogue Earth, or a giant molten star version of Earth, or just floating in the void with no sun at all. Could we survive in a binary system? Let's end on a hopeful note. If humans ever develop the technology to colonize other worlds, binary star systems might not be out of the question. In fact, exoplanets have already been discovered orbiting dual star systems, and some of these planets reside in their stars' habitable zones. The future of humanity might one day involve gazing up at two suns while sipping margaritas on an alien beach. Until then, let's cherish our single, perfectly sized sun and the delicate balance that allows us to exist. If your mind's officially blown, hit that like button and smash subscribe for more videos. Don't forget to ring the bell so you never miss when we shrink stars, explode planets, or break physics entirely. Drop your own crazy space theories in the comments. We might feature them next.